Hey, you guys, I apologize. I was going through this video for your 1.4 homework assignment, and then like everything just died on my end. My whole computer crashed. I don't know if it's because of the snow or what. I don't know what just happened. But so yeah, some of this is written down. I'm just going to go over it again for this video. So we start off with the statement, if the electricity is turned off, then the television does not work. And so we want to write the inverse, converse, and contrapositive of this statement. So first thing I did, I'm just going to cover this up. First thing I did was named P and Q. So from this, the if part, right, is my premise, my P statement. The electricity is turned off, then is P. And then the television does not work. That's the conclusion, so that's Q. The television set does not work. So then we can take P and Q and write the converse, inverse, and contrapositive. So the converse I started with because that's how your notes are set up. That's Q implies P, or if Q, then P. So if the television set does not work, that was Q. Then the electricity is turned off, that was P. The inverse is not P implies not Q. So if the electricity is not turned off, then the TV set does not, or sorry, then the TV set does work because it used to be the TV set does not work, so the opposite would be it does work. Okay, so I just negated both of those in the correct, PQ order. And then the contrapositive is we switch the order, so and negate. So not Q implies not P. So if the TV set does work, then the electricity is not turned off. So that's that. And then this is where my computer died. So we have this statement. All right, so two statements are equivalent if they are true and false under the same conditions. Which of the four statements do you think are logically equivalent? And then create a truth table to verify. So I started by creating the truth table. I've got P, Q, not P, and not Q that I finished. So this is just kind of the general setup for P and Q that we usually do. True, true, false, false, and then true, false, true, false. And then the opposite of P would be false, false, true, true. Opposite of this line right here. So that's where I got not P. And then not Q is the opposite of Q here. Okay, so false, true, false, true. All right, so now I'm going to go through, this is just our regular conditional. P implies Q. This is our converse, Q implies P. Our inverse, not P implies not Q. And our contrapositive, not Q implies not P. So just a reminder, that's kind of like the general setup for the conditional. This is only false when P is true and Q is false. So this is the only time that this is false and then the rest are true. It's kind of like our rule for the conditional. That's the only time, like if the order of our arrow goes from true to false. All right, so that's your true to false, P to Q. That's our only false time. Okay, so we're going to use that same idea, but now we're going to go the other way from Q to P. So from Q to P, true to true, that's true. From false to true, it's fine if we start with false, so that's true. But then here, if Q is true, that's our start, and it moves to false for P, that one is false for the converse. And then false to false is fine, that is true. All right, so it's a little bit different from the conditional to the converse. All right, then we're going to use these two columns. So we're going to use not P implies not Q. So here we don't want to go from true to false. So this first one's fine. False to false is true. False to true is also true. But then here we've got that true to false. So that one's false because it's a conditional, right? And then true to true is fine. So that's true. Okay, so already you may notice, I'm going to kind of highlight this. These are the same. So those are equivalent. The inverse and the converse are the same. So let's just do our last one to see if we have any other equivalent expressions. Not Q, so we'd start here and move to not P. So false to false, that's fine, that's true. True to false is where we get a false for the conditional. False to true is fine, and true to true is fine. And so then grab a different color. You may notice that the conditional is the same as the contrapositive, that same order. So we can write in conclusion, which of the four statements above do you think are logically equivalent? So the conditional and the contrapositive are equivalent, and then the converse and inverse are equivalent. Yeah. Okay. Next, we have only if statements. So I ride my bicycle only if it is not raining. So we want to determine the premise and the conclusion. Well, the part that follows only if is always the conclusion. That was part of our notes. So that would be S. So here we go. Premise would be I ride my bicycle only if it is not raining. It is not raining. All right, so then we're going to write the compound statement in if-then form. So this would be if I ride my bicycle, then it is not raining. And then interpret the conditions that make the statement in part A false. So we are going to have to make a truth table. Oh, I maybe should so let's make it. We've got R S. I'm debating, you guys. I should have made this it is raining so that we have the negation here. Okay, I'm gonna do it. Sorry, guys. So I made a mistake. This is all good to see. So remember, I forgot to do this. So okay, this might not work. We're gonna make this it is raining. So we need not S in here because that would be the not part. So I'm just switching that out. And so then this is the statement R implies not S. That's what we want to show. So we want to show when does that become false. Okay, so we make our regular truth table. This could be true or false. We have four possibilities because there's two statements. And I alternate on this one. All right, so then not S, so the statement it is not raining would be, let's see, false, true, false, true. And so then R implies not S. We'd have R to F, sorry, R to not S. So this is true to false. So that's where a conditional is false right away. True to true is fine. That's true. False to false is fine. And false to true is fine. So the only statement that makes this in part A false would be when I ride my bike and it is raining, because that's my new conditional up there, sorry, that I switched. So it is raining when those are true. So when I ride my bike and it is raining are true, then the conditions are false. That's the only time. That's the only time we got an S there. Okay. Next, you will pass math if and only if you do your homework. This is a biconditional, so if and only if is what that's saying. So we're going to write a statement using our symbolic logic. So we can just kind of go in order. I'm going to just say P is the statement you will pass math, and Q then is the statement you do your homework. And I could have switched those because it doesn't really matter the order on these. They work together, you know, in both directions. This is using the symbol both directions. P implies Q and Q implies P, biconditional, right? So arrows both ways. So list all the possible scenarios. The scenarios could be you passed math and you did your homework. It could be the opposite. You did your homework and you passed math, right? Because the order does not matter. So you did your homework and you passed math. Okay, and then also the negations of both can be true because they just both need to have like the same truth value, the same sign. So it could be the opposite of this would be you did not pass math and you did not do your homework. So you have to negate both. And we could switch the order of that. You did not do your homework and you did not pass math. There you go. Okay, so if the original statement was known to be true, which of the above scenarios must be true? So 1 and 2 would be true because you did pass, so you did your homework. So these would be true.